Alright, so here we are graphing functions and understanding graphing in terms of its parent. So if I see the parent, it's that. If I say, hey, what's the transformations? I would say, oh, on the outside it reflects and it's on the outside it reflects about the x-axis. And what direction are we going? Inside means left or right. It's going to the right. Ha. So right, how many? 1, and then on the outside it going up 7. So this is what I'm going to do. In pencil, I'm going to do the parent. So for an absolute value function, there's my parent, right? So what I want to do, and I'll do this in blue, is I want to translate that whole thing. So first of all, if it's going to reflect about the x-axis, it's now going to reflect down. And not only that, after it reflects down, it's going to go to the right one, and it's going to go up 7. So to the right one and up 7. And then from there, instead of pointing up, it would point down. I actually like doing this with points. So if you understand the parent points of 0, 0 and 1, 1, and it reflects across, if I go through the steps, the x, you would actually add 1, and for the y, you'd actually go times -1 plus 7. So 0 times anything 0 and add 7. So that's why we're at 1, 7. The next one will help us in terms of another point to guide us. So 1, 1, if I add 1, it becomes 2, and then 1 times -1 is -1, plus 7 is 6. So if I go to 2 and 6, that then guides me in terms of what's happening in this direction. That's what it is in blue. This has an axis of symmetry, so I can reflect over on the other side. They're linear, so as long as you know the slope in terms of direction, that's what it's going to look like. I actually have to continue this across the x because we're going to have to find the intercepts. There we go. So now at least I've drawn it far enough so we can analyze it. So can you tell me the domain? Well, the domain of any absolute value is going to be all real numbers. What's the range now? Well, the range actually, the bottom is actually -infinity, and it goes to the top point there. We said that top y coordinate is 7. So it goes -infinity to 7. Where does it cross the x-axis? Where are the x-intercepts? And one's at -6, and the other's at +8. Where's the y-intercept? Right there. So we have a y-intercept at 6. We have an extreme point up there. That extreme point is at 1, 7, and it is an absolute max because it's the top point. Where is it increasing and where is it decreasing? So it increases from -infinity to 1, and it decreases from 1 to infinity using the x values. What's the end behavior? Well, as x approaches infinity, what does the function approach? And it's -infinity. As x approaches -infinity, what's the function approaching? And it's approaching -infinity. Fancy way to say the right end and the left end are going down. All right, let's look here. 2. So the parent function here is y equals x squared. I am actually going to write down the parent points, 0, 0, 1, 1, and 2, 4. Very basic. What are the transformations here? So I'll say them out loud, but I'm going to transform the points and then put it on a graph. I think that's going to be a lot better than what I just did. So the x, what's on the inside? It's the inverse. So instead of like 1/4, that means divided by 4, you get the inverse. And the inverse of dividing is to multiply times 4. So every x gets multiplied by 4. 0 times 4, 1 times 4, and 2 times 4. Now the y coordinates, there's nothing on the outside changing it. So it stays, whatever those are. So we call this a horizontal stretch. Stays the same. There we go. So we're going to plot the points I just said, 0, 0, 4, 1, and 8, 4. And I'm going to reflect over. So there's an axis of symmetry, so I'm just going to match it on the other side. Oh, what did I do? Up here. There it is. And then it's going to look like a big bowl, parabola. There's one side. So can you see how the parabola has been stretched horizontally? That's why we call it a horizontal stretch. The domain is all real numbers. The range, the bottom of that parabola is 0, and it's included, and it goes to infinity. The x and the y-intercepts are at 0. We have one extreme point at 0, 0, and we call that the absolute minimum. Where does it increase? Well, starting at 0 to infinity, it increases. And from negative infinity to 0, it decreases. What's the end behavior? As x approaches infinity, what does the function do? Go to infinity. As x approaches negative infinity, what does the function do? Also goes to infinity. Number 3. What's the parent? X cubed. What are the parent points for x cubed? So I'm going to start with 0, and to get the answer 0. 1 gives me the answer 1. Negative 1 gives me the answer negative 1. I could do more if I want to put in 2 so that I can have a nice graph. 2 cubed is 8, and negative 2 cubed is negative 8. So now I've got to think, what's happening to the x's and y's? So nothing's happening to the x's, or else there would be a parentheses. Everything's on the outside. So it affects the y, and we're going to do order of operations. We're going to go times 2 and then subtract 5. So the x stays the same. 0 times 2, subtract 5. Let's do it again. 1 times 2, subtract 5. So this stays the same. 2 take away 5, that's negative 3. How about negative 1? So it's going to stay negative 1. And then negative 1 times 2 is negative 2. Subtract 5 is negative 7. If these go off my graph, I just won't graph them. 2 stays the same. 8 times 2 is 16. Take away 5 is 11. That's probably off my graph. The next one, negative 2. So negative 8 times 2 is negative 16. Take away 5 is negative 21. That's for sure off my graph. So let's start with the first 3 and see if I can even get there. So 0, negative 5. That's there. 1 and negative 3. 2 and or negative 1 and negative 7. 2 and 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's like way up there. So there's what the graph looks like. Domain is all real numbers, and the range is all real numbers. This is going to be kind of funky a bit. The y-intercept's easy. That's 0 and negative 5. That's where it crosses. Where does it cross? Here, somewhere between 1 and 2, right? So you could use a calculator to do it. We could actually make this equal and find the exact answer here. We could do that. So if I make it equal to 0, could I easily figure out what the exact answer is? Well, the inverse of subtracting 5 is to add 5. The inverse of multiplying is to divide. And then cube, you'd actually cube root. So where is the x-intercept? It's actually the cube root of 5 over 2. And we use that from the equation. That's somewhere between 1 and 2. There are no extreme values, but we know at 0 and negative 5 we have a point of inflection. So it's not an extreme point, but it is a critical point. Where does it increase? Everywhere left to right. It's going up. It has nothing to decrease. What's the end behavior? As x approaches infinity, what's the function doing? It's going to infinity. As x approaches negative infinity, what's the function doing? It's going to negative infinity. All right, number 4. Turn the page. What's the parent here? The square root of x. I'm going to write down the parent points, which are 0, 0, 1, 1, and the square root of 4 is 2. Nice and simple. No negative numbers, because you can't take the square of a negative number. Now, what's happening on the inside? What's happening on the outside? So on the outside is pretty simple. It's a vertical stretch times 3. So I'm just going to multiply everything times 3 for the y. Nice and simple. On the inside, 2 things are happening, and I need to be aware of both things. So first, you have a negative. So ultimately, you're dividing by -1, if you want to think of that, or you're changing the sign. It's the opposite sign to what you see, and then you're going to add 2 after that. So 0 stays 0, the negative doesn't affect it, and then add 2 and it becomes 2, 0. Here, the negative makes this a -1, and add 2 and it becomes positive 1. The negative makes this a negative, what am I looking at? Here, 4, the 1 stayed 4. The 4 becomes negative, and then add 2 is -2. There you go. So, let me go back to my blue. So 2, 0. 1, 3, and -2 and 6. So I'm just going to turn my page a little so I can curve it the right way. Think of it like a parabola on its side. So think of a sideways parabola or a shooting star going up to the left. There's the graph of that square root. Could I analyze it? So the domain, what's the far right going left? So the left part of the domain is negative infinity because it goes now to the left. But what's the right value there? And it's included. So it goes from negative infinity to 2. How about the y value? We have a bottom y value. That's 0, and it goes to infinity. X-intercept, it's right there. I'm pointing at it. It's 2, 0. The y-intercept, it's right here. 1, 2, 3, 4. Actually, it's probably something else than 4. If you want to find the y-intercept, you plug in 0, and what you actually end up with, let's be accurate here, it's very close to 4. But if I plug in 0 for x, the negative and the negative makes it positive 2, and the square root of 2 I can't. It's irrational. So it's really 3 root 2, and 3 root 2 is very close to the number 4. Any extreme points? Well, we do have an absolute minimum. And where is the absolute minimum? At 2, 0. Where is it increasing? Left to right? How about decreasing? Yep, from left to right. Using x coordinates, it's 2. So from negative infinity to 2, it's decreasing. End behavior? Well, I like the left part. So if as x approaches negative infinity, what's the function doing? It's going to infinity. So it really has one end behavior. It has an end point right there. All right, number 5. I know this takes practice and some discipline and some work to get stronger at knowing how to do these graphs. Parent, cube. So we write down the cube root of x. I'm going to write down the parent points again. So for the cube root, 0, the cube root of 0 is 0, cube root of 1 is 1. And then for cube root, we're actually going to go up to 8 because the cube root of 8 is 2. We also have -1, -1, and -8, -2 if they fit on my graph. So what number 3 times itself equals 8? And the answer is 2. All right, so what's happening on the inside and outside? So outside is easiest, so we'll start there. So on the outside, we're adding 4. It does what it says. So I'm just going to add 4 all the way down. Inside, there are 2 things happening. So So I do the inverse of what I see. So I got to divide by 2 and then subtract 1. So 0 divided by 2 is 0 and then subtract 1. 1 divided by 2 is a half and subtract 1 is negative a half. 2 divided by 2 is 1 and subtract 1 is 0. Negative 1 divided by 2 is negative a half, subtract 1 is negative 1 and a half. And then negative 2 divided by 2 is negative 1, subtract 1 is negative 2. So we have points to plot. So I'm going to go to negative 1 and 4, negative a half and 5. I'm going to go to 0 and 6. So the inside is creating a horizontal compression in terms of what's happening. And it's also been lifted up 4 and to the left 1. So we also have negative 1 and a half and 3. And negative 2 and positive 2. Remember the curve of this. So as you're curving it, remember what the curve is going to look like. Kind of looks like an S. What's the domain of this? It's all real numbers. What's the range? It's all real numbers. Intercepts. So the y is easy. I'll go easy first. The y is at 6. The x, it's somewhere way here to the left. If I wanted to find it, I can take this and make it equal to 0. And then solve it. So if I subtract 4, and then the inverse of that is to cube it. So let's do that first. So negative 4 cubed is negative 64. Then it gets easier. Divide by 2, and it's negative 32, and then subtract 1. And so we get negative 33 as the x-intercept. So that's way down there, way off my graph. Any extreme points? No, but we do have a point of inflection, and our point of inflection is at negative 1 and 4. Increasing all the way through. Nothing decreasing. How about the end behavior? As x approaches infinity, what's the function doing? Going to infinity. As x approaches negative infinity, what's the function doing? Well, it goes to negative infinity. Done. Number 6. Parent function. Just the reciprocal. So for a reciprocal, we do have 1, 1, and negative 1, negative 1 that are helpful. But we also have two asymptotes at x equals 0 and y equals 0, and that could shift as well, but it won't be stretched or compressed. It will just be shifted around if there's something to shift it. So what's in the numerator affects the y. What's in the denominator affects the x. So for the x, we're going to subtract 3. Again, subtracting 3 will change this to negative 3. To the y, we're going to go times negative 4. So when I multiply it by negative 4, see how the sign changes? But 0 times negative 4 is still 0. So I'm going to put colors down. So at negative 3, we have an asymptote. And at y equals 0, we have an asymptote. I'm going to plot negative 2 and negative 4. I'm going to plot negative 4 and positive 4. So I have 2 points to go from to curve through. What I know about the behavior of a rational function is that at a vertical asymptote, we will either go to a positive infinity or negative infinity. So the one below is going to negative infinity, and the one above is going to positive infinity. It's not just going to cross the horizontal axes. What else do I know? Is that the end behavior of this is going to go to the horizontal asymptote. So as this curves up, it's going to go to the asymptote. As this curves down, it's going to follow the asymptote, which gives me the end behavior. So the domain of this is all real numbers, but x cannot equal -3. The range is all real numbers, but y cannot equal 0. That comes from the asymptotes right here. X-intercept, none, doesn't cross. The y, well, what happens when I plug in 0? You can see exactly what the y is. So just plug in 0 and you get -4/3. Extrema, so that means this below -1. Probably could have been just a little bit higher when I drew the curve. There's none. So there's no point of inflections, nor their maximums or minimums. Where is it increasing? Or from left to right, it's increasing. So it's increasing from -infinity to -3, and from -3 to infinity. So increasing, increasing. Nothing at decreasing. What's the end behavior? So as x approaches infinity, the function approaches the horizontal, which is at 0. So again, as x approaches -infinity, same thing, but on the other side, the left side also approaches 0. Turn the page. Make sure I have enough time here. Hope so. Parent, the cube root of x. What are the transformations? Let's list the parent points. To have at least a sense. I might not even do 8, 2. What do I see on the outside? I see add 4. That's easy. So if I add 4, you can see what this does to the y. And then inside, -1/3. So I'm going to do the reciprocal of that, -3. So 0 times -3 is 0. 1 times -3 is -3. And negative times a negative is positive, so it's +3. So I'm going to use those points and curve from there. So 0, 4, because when I do this, it'll be 24. It's not going to be on my graph. So 0, 4, -3, and 5. +3 and 3, and then curve it. Remember, it's going to look a little bit like an S when you curve this. A flattened out S. So you can see there's a horizontal stretched out left and right, make it look a little wider than it would have been before. The domain and range are all real numbers. The x-intercepts, it will have an x-intercept. So how I would find the x-intercept is I'd have to solve it. So how I would solve it is I make it equal to 0. And then solve it. So I would subtract 4 and cube it again. Remember doing that. That's -64. And then I go, it's -1/3. So to undo the -1/3, it's times -3 to both sides. So -64 times -3, it's a positive answer, and it's a positive 192. So this is 192 and 0 over here to the right. The y-intercept, yay, that's much easier. That's 0 and 4. We have a point of inflection, and that's at 0, 4. Where is it increasing? Nowhere. Where is it decreasing? Everywhere. Left to right, going down. As x approaches infinity, what is the function approach? At -infinity. As x approaches -infinity, what is the function approach? That would be positive infinity. Number 8. Parent function is the reciprocal, 1 over x. I'm going to put down the points 1, 1, -1, -1, and the asymptotes that go with it. What's happening here? So the -1 means it's being shifted down 1. So if you shift it down 1, what's going to happen? So that affects the asymptote as well. 2, I'm actually going to divide by 2. So the x gets 1/2, and here it gets -1/2. And here, dividing by 2 doesn't change 0 at all. So I'm going to go here at 0, and then at -1. So I'm going to find 1/2 and 0. Goes up and then down. And I'm going to find -1/2 and -2. And then curve it. So you can see the two curves. The domain is all real numbers, and the one number x cannot be is 0. The range is all real numbers, but the y in this case can't be -1 from the asymptotes. X-intercept, hey, I just did it, so it's 1/2 and 0. The y-intercept is none, because there's an asymptote over the y-axis. No extreme points, increasing, down, down, nothing. So from -infinity all the way to 0, and from 0 to infinity, it is going down and then down, left to right. End behavior, as x approaches infinity, the function is going to approach the horizontal asymptote, which is -1. Same thing here. It's going to approach -1 from both ways. Number 9. Parent function, the absolute value of x. We are going to get some points to make life easier and then reflect over them. So 0, 0, 1, 1, and 2, 2. And then what's happening? So to the x, it actually is easier. Subtract 2. To the y, we're going to do divide by 4 and add 5. So 0 divided by 4 is 0, and then add 5. So let's start there. So I'm going to go to -2, 5. For an absolute value function, because I'm going to get 1/4 and I'm going to get 1/2, it actually provides the slope that I go to. So when I want to draw this, what's the slope? And it goes up 1 and to the right 4. And then it's up 1 and to the left 4, because it's a V. So what are the transformations that took place for this? So you can see the 1/4 is a vertical compression. It's squished down. One to the left 2 and one up 5. So what's the domain here? Well, it's all real numbers. What's the range? Well, we have a bottom number from the vertex, which is 5. So it's 5 and up. X-intercept, none. It's not going to cross. The y, we do have a y right here. So if I want to find the y, I plug in 0 for x. And so the absolute value of 2 divided by 4 is 1/2 plus 5. So it's actually at 5.5. You could write this 11 over 2 if you wanted to. Where's the extreme points? Well, we have one down here. That's actually an absolute minimum. And for the absolute minimum, that point was at -2 and 5. So the absolute minimum value of the function is 5. Increasing and decreasing. So from increasing, we start at the vertex, or the x value. So from -2 to infinity, it's increasing, but from -infinity to -2, left to right, it's decreasing. What's the end behavior? Well, as x approaches infinity, the function's going to approach infinity. As x approaches -infinity, the function's going to approach also infinity. Left and right end are going up. All right, last page to practice. And that's how we're going to get stronger. Then there's even another sheet to practice after that. But we'll do this video up to 12, I think. Hopefully the bell doesn't ring. All right, what's the parent? It's a parabola, x squared. Let's just put down some parent points that we know for a parabola, 0, 0, 1, 1, and 2, 4. What's happening outside and inside? So outside, inside is easiest, adding 4, the inverse. So I just added 4 to this, the y, times -3 plus 6. So 0 plus 6, 1 times -3 plus 6, 4 times -3 is -12 plus 6. So now we have some points to plot. So 4, 6, 5, and 3. And we're going to reflect over. There's an axis of symmetry right here too. and then 6 and negative 6. And reflect over. You can see it's a skinny looking parabola going down. So this has a vertical stretch reflecting down. And we went to the right 4 and up 6. What's the domain of this? Well, it's all real numbers. The range, well, the bottom to the top. So the bottom is negative infinity, and then the top is 6. And it's included. X-intercepts are right here. If I made that equal to 0, I could find them. So I would subtract 6 and divide by negative 3. That's 2. And then it's the plus or minus the square root of 2. So it's plus or minus. This is square root. And then you would add 4 to that. So we have 4 plus or minus the square root of 2 and 0. This is where they cross, the exact answers. The y-intercept, if I put in 0 here, I get 16 times negative 3, negative 48, plus 6 is negative 42. It's way down there. So I did that algebraically, not off the graph. We do have one. We have an absolute maximum, and that point is up here, which is at 4 and 6. It's increasing from negative infinity to 4, decreasing from 4 to infinity. As x approaches infinity, the function is going to approach negative infinity. As it goes to negative infinity, the function is going to approach negative infinity. So both ends are going down. 2 more. I hear that bell. It's going to come. So the absolute value, this is not absolute value, greatest integer. So what are the transformations? It's going to go left 1 and down 3. So normally it starts at 0. So if I go left 1 and down 3, here we are. I'm just going to start there. And it's a step. So step, and then it's a hole, and then up. There goes the step. Hole, step, hole, step, hole, done. And so you could fill it out exactly like that. So it's the greatest integer function less than or equal to what's inside. Boom. Hey, what's the domain? It's all real numbers. The range are all integers. The x-intercept, you can see, is 0. Or here. Is 2 to 3. So he actually touches at 2, touches at 2.5, touches at everything from 2 to 3 are the x-intercepts. The y is at 0, negative 2. Extreme points, no. Increasing, I guess it's increasing going to the right, even though there's these constants in there. Decreasing, nope. And behavior, I'm not going to worry about. It's not that kind of function to understand and analyze it this way. Number 12. Another one, just like it. Love it. Greatest integer function. So what's happening here? So I'm going to go 4 to the right and 1 up. There's going to be my first. Now, what's the negative going to do? So it's, instead of going up to the right, it's actually going to go now up to the left. And the 2 means I skip and I go 2 at a time. So here's my next step, and then 2, and here's my next step. So notice how that 2 makes me skip a step, and instead of going up to the right, these steps are now going down to the right. So the domain is still all real numbers and integers. What I care about, x-intercepts and so on, there's actually no x-intercepts because it's going to skip the x-axis. The y, eventually as it goes up to the left, it's going to hit the y at 9 as we go up. The extreme, there's really this part here, it's decreasing really throughout the whole thing if you want to think of it that way. Same with that in terms of end behavior. So it's a unique function. It's really used a lot for in calculus, what we use for limits, as a way to really understand the concept of a limit. Anyways, great practicing. There's another sheet after this. I'll do a video on that right after this. All right, good job.